let's talk about pallets. So pallets at a high level, they're pieces of business logic for your runtime, right? And they're modules, they're like Rust modules that we call pallets in the Substrate framework world. What you see on the screen, that's the Polkadot SDK repo. I actually have it cloned. Here it is. So you can see the full repo here on the left-hand side in the navigation. And inside of the Polkadot SDK repo, there's a folder called Substrate. And it happens to be that this is the Substrate framework, right? It's a Rust-based framework. It's what it was used to build Polkadot, and it's also what's used to build Substrate-based blockchains, whether it's a solo chain or a pair chain. So let's take a look inside of it. One key folder that I want to show you is Frame. So Frame is a little framework that you can use to build runtime logic, right? And what you see inside this folder, each one of these folders here, Alliance, Asset Conversion, Asset Rate, and so on, each one is a pallet. Okay, so if I were to expand, for example, assets, like what is this? This is a pallet. So what is a pallet? It's encapsulated logic, business logic. In this case, it's logic around assets. So if you want to have a parachain or a blockchain or solo chain that consists of asset logic, right? Think tokens, right? The different things that assets can do, then you'd use this palette here. If you want to have logic around, let's say, let's look at another one here, identity, right? You want to have identity for your blockchain, then you'd use the identity palette, right? And so on. There's various palettes. I would say my favorite one is the NFTs palette, and it has all the logic around NFTs. So if you want to build a blockchain, a substrate-based blockchain with NFT logic, like the ability to create NFT collections, mint NFTs, do all kinds of crazy, like cool stuff with NFTs. If you want that baked into your blockchain, right, then you'd use the NFTs palette. Now, this is blockchain logic, right? So this will go into your blockchain, right? This isn't like a smart contract that goes on top of your blockchain. This is actually business logic that goes into your blockchain's runtime. And the beauty of Substrate when you're building a Substrate blockchain is that today you may decide that you don't want NFTs. You want to start your blockchain with assets, for example, right? Uh, it has the capability to manage assets, create new assets, uh, and so you use the assets palettes today. But then maybe tomorrow you say, well, okay, our team feels pretty comfortable with assets palette. Now we want to add the ability for our blockchain to support NFTs. And with Substrate, that's possible because Substrate was built from the ground up to support upgrades. So all you'd have to do is add the NFTs palette to your blockchain and then do a runtime upgrade for your blockchain. Boom, your blockchain now supports NFTs, right? And we'll do that runtime upgrades in another video. Today, I just want to talk about palettes. So this is what palettes are. I invite you all to like go through this folder, pick some of them that you love, that you think that are pretty cool, like NFTs, for example, and just like go through the folders, go through the files and read it, right? So start with the cargo.toml file and just like see what the dependencies are. Like you can see here, you have frame system and frame support, and you can see that the dev dependencies here is palette balances for testing purposes. And then you have your STD down here, the frame support frame system. Once again, runtime benchmarks and try runtime for testing your runtime. Okay. So the cargo.toml file is pretty simple for palettes. And each palette has a README. So you can read a little bit about the palette itself, the documentation on the palette. But most of all these palettes that are in the Substrate folder, they've all been audited, right? So that's a peace of mind. So they're production ready. And the other thing is that they all have excellent documentation in the code itself. So inline documentation, like for example, if we look at the librs, which would be the next place that you'd like go into the palette, you can see that it's documented there, NFTs module, right? This is the NFTs palette. It's a simple, secure module for dealing with NFTs, right? And you can see the related modules, and we saw that, that's included in the dependency. And then simply start reading it. and going down through the code and seeing how it's configured, right? This is a pretty large palette. It incorporates a lot of NFT features. It's an excellent palette to learn also best practices. You can see that it's pretty modular. Like there's a features folder. Each one of these approvals, atomic swap, attribute, each one is a feature, right? So it's a good way to kind of learn like best practices to see a production ready palette. Today, we're not going to go into the NFTs palette. It's a large palette. Today, I actually want to go into like a Hello World palette, right? So just wanted to show you where all the production ready palettes exist inside of Frame. And now what I want to do is hop from the Polkadot SDK repo to the solo chain template. So this solo chain template is a substrate based solo chain, right? So with this, you don't have to connect to the relay chain. It just runs on its own. So it's a great like kind of like starting point to just like learn substrate blockchains. And I already have cloned this down. So I have it, I believe I have it here. Yep, Polkadot SDK solo chain template. And you can see it's a lot smaller. It's like you can breathe, it's like, okay, this isn't overwhelming. It's a good starting point to just like learn blockchain, learn substrate-based blockchains. The hierarchy here and the folders, it's really well organized. There's one called palettes, the one that we're interested in. And there's a Hello World palette here. You can see it's called template. And it's got a README, right? And the README's got absolutely nothing there. It's got a cargo.toml and then it's got a source. So where our palette would be. So if you were creating a palette from scratch, right, this is what that's showing you. Like if you have an idea for some business logic for your runtime that doesn't already exist inside of Frame as a production ready palette, right, and you want to create your own palette, this is kind of like a Hello World palette, right? So you have your main business logic here, you have your unit tests here, and in your logic, in your librs, you can see that this one is super well documented. And you can see right here, that's where our palette logic kind of officially starts. And you're declaring your palette here as a struct. And every palette is going to have a configuration so that the runtime uh, can pass in whatever configuration it is needed. Typically, almost all palettes like emit events. So you're going to have this runtime event. And then you're going to have the API of your palette, or I'm sorry, the API of your pallette's down here. So right here, the API of your palette. So like what I mean by API is like, what can you do with this palette, right? Well, this one has a function that's called do something. So from the runtime, I could call this and I could call this do something function and it'll do whatever logic is written here, right? So these are called dispatchables in the Substrate language. And from the outside world, this is what's called an extrinsic, right? So outside of the blockchain, it's called an extrinsic, and here on this level, it's called a dispatchable function. Okay, so you create your dispatchable functions that you can communicate with, and this is the business logic for your palette and for your runtime, right? At the end of the day. So when you're creating these functions, often you emit events like, hey, this happened, right? So the outside world knows that something has happened. And you can also have errors that you create. Usually when you're creating a palette, you also need some type of storage. So it's common that you create have some storage where you can store certain values. And in another video, we're going to go over like palette development. Today, I just want to go over like configuring a palette, right? And just show you like introduction of like this palette, for example, how would I configure this in my runtime, right? This palette is already configured in the runtime. You can see in the runtime here. And if I go into my cargo.toml, this is the first part where you'd configure your palette. So in the runtimes cargo.toml, you have to add the palette as a dependency. You can see there's already a few palettes here added, and there should be one here called palette template. And there it is down here. Palette template workspace true. Okay. So this is workspace true. So that means that it's configured here. And if you open here and go one level higher into the root cargo.toml, we should see that the palette template is there as well. So if we scroll down right there, and you can see the path of palette template, it's actually, it's local. It's inside that folder. Okay. So it's configured there as a dependency. The other thing that we want to see inside of the runtime.cargo.toml is not only do we want it as a dependency, but down here in the STD, we want to include it here. So there should be a section, palette template STD. Okay, so we want to make sure that whenever we're including a palette, we need to include it here as well. And if we want to have runtime benchmarks, we also want to include the palette here. So we'll cover benchmarks another day, but think in terms of weight, right? Because like this is a solo chain. So to run the logic of this palette on the solo chain is going to be different than running the logic of this palette uh, on a parachain, right? The cost of execution. So that's why we need benchmarks. And then finally, if we want to support try runtime, so try runtime is a way to test our runtime. So this is useful if we want to do runtime upgrades. And you don't always need this as a dependency, but if you're going to use try runtime with this palette, then you want to include it here also as a section right there. You can see it there, palette template. Okay, so those are different places that you need to include the dependency for your palette when you're adding it, configuring it into your runtime. And that's what we just saw, right? And then the second place that you need to look at is inside the runtime, the source. We have to look inside the runtime. So librs, right? So this is the librs file for the solo chain. It's a lot simpler than the librs for the parachain. And at the very bottom, so like here you can see um, there's a lot of configuration for a blockchain. Like in this blockchain, what consists of like a unit, right? A unit is this large number, right? So one unit is this huge number, right? Why is it this big? It's because uh, substrate blockchains don't support decimals, right? So if it doesn't support decimals, then how do we do precision? Well, we set the default unit, the base unit, as a very large number so that we can have precision. Okay, that's an interesting little fact. So if we scroll down right here, module runtime, and then in here specifically, struct runtime. This is where we're kind of like creating our runtime and we're defining what goes into our runtime. So what goes into this runtime? Well, the frame system palette, the palette timestamp, palette aura for block authoring, uh, palette grandpa for finality, palette balances so we can have balances, palette transaction payments so that we can have uh, fees for our transaction, palette pseudo so that we can have some type of governance. And then finally, this is where when we're configuring our palette, we want to make sure that our palette is here. And in this case, it's palette template and it's included here, right? In the struct runtime. So all of this is our runtime. Like we're configuring our runtime here and we're adding this palette here. And every time we add a palette, we add an index. So in this case, it's index 7. And if we want to add another palette, it would be index 8. And these are kind of like, um, you want to keep these consistent. Like tomorrow, I don't want to change this to like palette pseudo to like index 9. That would be actually a breaking change. So if palette pseudo was configured to index 6, we want to keep it at index 6 forever. Because this is like the API, right, to the external world. Like when, like other libraries are communicating with our blockchain, they're expecting that palette pseudo will be at index 6. So if we do that, if we change it to index 9, it's going to be a breaking change because it's no longer going to exist in index 6. Okay. So we want to keep that consistent. So pick numbers that are logical. So we include it there, palette template. And then finally, um, we want to make sure that if the palette itself has any configuration. So what do I mean by configuration? Well, remember how inside of our palette, there was a palette config here. In this case, the configuration is super simple. It's just like runtime event and wait info. But it does have a configuration. So in our runtime, in the runtime folder here, we want to go into configs mod rs, and this is where our palette configurations are implemented. So if I scroll down, you can see here's the frame system configuration for the runtime. And if I keep scrolling, you can see the different palette configurations. And at the very bottom, we're going to see palette template right there. So this is the configuration for palette template. So we're basically saying, uh, hey, palette template needs to know what's a runtime event. What is it? And we're specifying, well, this is what a runtime event is. Okay. So this is defined. If we do if we look up here, if we do a find, it's actually imported here, right? And we can see it's imported from super. So if we go into a librs and we do a find for runtime event, and there it is. Okay. So it's coming from there, which is coming from frame support. Okay. So frame support's really useful. Um, the other thing, like if you look at the other palettes, like a better example, it's like frame system, right? Frame system wants to know what is a block, right? And so like we're saying this is a block, right? And this is also getting imported. If we look up here, should be getting imported uh, right here. So it's probably also coming from frame support. So you can see frame support. This is probably all coming from frame support. It's really handy, right? The frame support palette. It defines a lot of useful things for our blockchain. So a more like simpler configuration, like if we look at maybe we look, let's see, palette. Yeah, let's look at palette balances, right? So in this case here, we're looking at the different configuration for palette balances. So um, this one here, it's giving a number of 50 for maximum locks. So you're only allowed to do up to 50 locks. Uh, this one here, it's specifying the existential deposit, right? And it's defined as a constant here, existential deposit. So if we do a lookup for existential deposit, it's defined here. So if we go super, we go into the librs of the runtime, and we look for existential deposit. There it is. So existential deposit is of type balance, and it's the existential deposit is milliunit. So this is the amount here. That's the existential deposit for our blockchain. Okay. So that's pretty much like the pipeline of like configuring the palettes. So we define here, right, the configuration that we specified in our palette configuration. So in our palette configuration, in this one, it's very simple. Okay. So that's it. That's pretty much how you configure a palette. And then if we want, like we can run the blockchain to make sure, that we configured it properly. So I believe it's right here. So if we go here and it's spinning up the blockchain. So if I open up the browser, we should see palette template there, port 9944. So if I go to like developer extrinsics and open this up, there's a palette template module. Okay. Cause error and do something. Why is it called template module? Well, if we look back in our VS Code, in our palette logic, which this is what we see on this screen. Well, actually, it's in the runtime. So we go librs where we added the palette. It's because here we call it a template module. So if I were to call it like developer module, then here it would be called developer module. Okay. So that's pretty much it. We could now, if we wanted to, we could interact with our palette. We can go into change state and we can see that the palette is there and like look at the palette, right? Uh, so yeah, like actually, if we look, what does do something do? Uh, store a value. So if we look at the dispatchable origin, something U32, okay, put, okay, very simple. So we could test that. Let's see, something, go to extrinsics, and you can see now it's called extrinsic, right? Because we're outside of the blockchain, do something. I'm going to store the number 12, submit transaction just to test it. Inability to pay some fee. Well, yeah, because let's see who has money. Let's try Alice. So do something 12 and then submit transaction. Let's use Alice instead of 30. Alice. Alice has money. Alice has assets. Alice has a lot of money. So there it is. It's in the block. And if we look, actually, the event was fired off, something stored, right? That's pretty cool. So if this something stored, we can see that in there should be an event here. Let's see right there. So pallet event, it's an enum, something stored, right? And so it's there. The event got fired. And actually, if we check change state and we say template module, something, and just hit enter, and there it is, 12. So something, if we look at the storage here, right, there's something, storage value, right? So we're storing there 12. Okay, so you can see this video was just to show you how to configure a template into a runtime, so a palette into a runtime. Okay, so that's pretty much it in a nutshell. The hello world version of that, right? From here, you can try creating your own template. Uh, from here, you could try to use a production ready palette from Substrate and configuring that into your runtime here. You could definitely configure it, like if I collapse this, you could definitely configure it here, right? You could technically say like, I want to configure NFTs palette here, right? That's a good exercise. I would say the only thing that's missing for you to configure a palette like that, really, there's nothing missing, but a good cheat sheet that I'd like to show you that helped me a lot. Like it's really useful. Like I have the Polkadot SDK repo open on my computer right here, right? We're looking at it. So inside of the Substrate folder, there's what we call a kitchen sink node. So it's inside of the bin. So bin, node, and if I scroll here, runtime. Kitchen sink node means it's got everything, right? Everything's in the kitchen sink. It's just like everything's there, all the plates, all the spoons, everything, right? So this has everything. So if I look at the runtimes librs and I scroll through it, you're going to see, right, all the palettes that we saw inside that frame folder. Like they're all there, right? So it's like a little cheat sheet if you want to know like how to configure a palette into a Substrate runtime. This is a good like little cheat sheet to look at and get some ideas of like how to do it, right? So for example, palette assets, right? This is the configuration for palette assets. So like if I were to look at in my runtime, uh, well, this is the runtime. If I were to look at the frame folder and look at palette assets, the actual code for palette assets, and go to librs, so this is assets palette. And if I scroll down, you can see how really it's amazingly documented. If I scroll to the configuration, let's see. So it's got a default config. Here it is, config. Okay. So we can see runtime event balance, right? Like what is a balance, right? Whatever a balance is, it has to adhere to these these traits, right? Um, remove items list, right? That needs to be a U32. Uh, asset ID, right? That's the configuration currency, create origin, force origin, and so on. It's got a lot that it needs to use, right? Like, so if you had to like, if the exercise was like, okay, take palette assets, go to your solo chain, right, and add pallet assets here, it's not too intuitive, right? Like you got to be really, really good with Rust to make sure not only Rust, but like understand what you're doing, right? To make sure that you have the proper configuration here, right? So it's really useful to go to that kitchen sink node and say, okay, like let's see how like this demo, this example of configuring pallet assets, right? Okay, they set balance to type U128. They set asset ID to type U32, right? Currency, they set it to balances, right? Create origin, this is how they did create origin, right? It's not the only way, right? Force origin, ensure root, right? Like it's not the only way. Like if your blockchain isn't using pseudo or anything, right? Maybe you want force origin to be a collective or something, right? Or some other, like if you're using a ranked system, maybe something else, right? So it's not the only way. Asset deposit is configured where? So if we were to like look asset deposit, start looking up here, it's configured as a constant. So this is how you can configure constants, parameter types, and you can see it's set to 100 times dollars. So dollars happens to be in our Solo blockchain, we weren't using dollars, right? So this is a blockchain configuration. Like this is our Solo blockchain here. If I scroll up, we have unit, right? Not dollars, right? So if I go back, we have dollars. So this is in the kitchen sink node. If I look, I believe maybe constants. Let's see. Yeah. So inside the constants file here, we can see we're defining dollars. So what is dollars? Well, dollars is 100 times cents. Okay. So what is cents? Well, here's cents. What's millicents? Here's millicents, right? So dollars is 100 times this number here. Okay. So this kitchen sink node uses dollars, right? Maybe your node, your blockchain node has a different name, right? Maybe it's your token or something, right? So this is specific to this blockchain, which is interesting, right? It's interesting to look at. But if we go back to pallet assets, right, you can use this as a guide when you're configuring pallet assets in your runtime. And I can't tell you how useful this has been when I've been configuring palettes into my runtime. Okay, especially the more complex palettes, right? And sometimes there's palettes that work with other palettes, right? So like, let's see, Treasury palette, Treasury. There it is. Okay, so this is Treasury palette, the configuration for Treasury palette. And what's cool here, like I'll give you one cool example. If we say, let's see, spend funds, it uses the bounties palette for spend funds. So this is an example where it's like this palette is configured to also use another palette. So we would need to make sure that, you know, in this case, the bounties palette is configured. There's also another cool one, I believe, burn. So like, let's look at burn, right? So burn is burn. So if we copy that, look that up, let's see. Okay, here's the constant. So burn, okay, so percent, 50%. Okay, so burn is set to 50%. We'd have to look at the palette logic to see what that actually means. Um, Cedric, this is cool. This is, I believe this is what gives the key to the palette, to the treasury, right? Because the treasury actually has an account ID. Yeah, right here. So treasury palette ID right there. Um, this would be a video in itself. This is actually pretty cool if you look at the code for that. But let's look one last one here. So spend period. Uh, okay, assets. This can be configured differently. Yeah, maybe this one doesn't have another one, but there's palette membership. This is interesting. Yeah, I'm trying to find a palette that uses another palette, right? So for example, let's look, is this one palette collective? Okay. Um, maybe what's this one? Palette democracy. Yeah, this one. So palette democracy, right? It's a governance palette. You can see that for these different origins, it's using palette collective, right? So um, that's a good example of for its origins, it's using a collective. Like it could use pseudo, right? The pseudo palette. But in this case, it's using a collective, which makes more sense, right? Because it's governance. So that's pretty much it. I mean, there's a lot more to it. I would like to do, more in-depth videos, but I'd say like this is a starting point, right? From here, a good exercise is to try to configure your own uh, palette into the Substrate solo chain runtime. So I would say like try picking a palette that isn't too bad. Like pick a simpler one. Something that's a little bit simple, like you can look through the kitchen sink node and then try to add it into here, right? Into your cargo.toml, into your librs, the config, and then compile it, make sure it compiles. Usually what I like to do is first add a dependency to the cargo.toml and then compile it, make sure it compiles. That way you get a green flag and then go to the next step, adding it to your runtime, adding it to your config, and then making sure it compiles again. Instead of doing everything and then hitting compile and finding out that you get a million compile errors, right? So step by step, that gives you some sanity because one of the things with this stuff is that sometimes if it goes wrong, you can get hundreds of errors and that can get overwhelming when in fact it was just like one line of code that was wrong, right? So just start with step by step. All right. So thank you all. Happy hacking.